All right, in this video, they want us to graph the following function and find its domain and range. All right, so when we look at f of x, you can see it's a piecewise function. Basically, they're defining the function across the x-axis from -4 to positive infinity, but the portion of the function from -4 to 1 is different from the portion of the function that goes from 1 to positive infinity. All right, so let's go ahead and graph this function. What you want to actually do is graph each piece separately across its domain. So in other words, we're going to look at the first piece here and just find x and y for that first piece. So 2 minus x for that part of the function. So what happens if you plug in, for example, -4, which is a suitable value for the function here? Well, you'd end up getting 2 minus a -4, right? So 2 minus -4, or in other words, 2 plus 4, so the answer is 6, right? And then if you did the same for that function, but this time using the value 1, now I understand you may be saying to me, hey, well, 1 shouldn't be used here in the function. We're going to use it anyways, and we'll talk about why. So we're going to let 1 go in here. I'm going to put a little asterisk here just to remind us that 1 is not really supposed to go into that part of the function, right? Because it says that we have to use values that are strictly less than 1. All right, but let's go ahead and plug 1 in anyways. So we'll have 2 minus 1, which of course gives you 1. So we're going to put 1 there. Now, if you want to, you can plot a value between these two if you'd like. For example, you could put 0 into the function. So 2 minus 0 is just 2. And you could do that if you'd like, but remember, 2 minus x is just going to form a line, right? Because that x is to the first power. So if we have 2 points of the line, we can then plot the line. Now, the reason why we use this point 1 for x, so 1 comma 1, is because we want to know where the line will end, basically. Even though we won't actually arrive at that point, it'll go right up next to that point without touching it. So the way we're going to indicate that is by using an open circle on that part of the graph. So let's start with the 2 points that we can plot on the graph, -4 and 6. All right, so if we go up 6 on the y-axis, 1, 2, 3, 4, 5, 6, let's say, then -4, +6 is going to be way up here about there, correct? And then if we did 0, 2, it'd be 0, 1, 2, about there. And then 1, 1 would be 1, 1, but here I'm going to put an open circle. So I'm leaving an open circle there to indicate that we're going to get right next to that point, but won't actually arrive at that point. And then it's a line, so I'm just going to kind of connect these with a straight line, and that's it. Now, I was actually about to extend that beyond that point, -4, but remember, we don't have any values on the x-axis past -4, because the domain here for this function, it looks like it starts at -4. So we're going to go ahead and just stop there at -4. We won't put an arrow on the end of that line like we normally would. All right, now from there, we want to go ahead and plot the second piece of it. So the second piece of the function is the square root of x, and we know that looks like half of a parabola on its side. And they're restricting the domain here. They're saying basically only plot this for x being greater than 1. All right, so you can't put 1 in there, but again, we're going to do it anyways. So let's go ahead and do that. If you were to put 1 in there, and again, asterisk here to let us know that we're not supposed to put 1 in there, but if you did put 1 in there, you'd get 1 out, right? Because the square root of 1 is 1. All right, so we'd get that same point 1, 1. That's important because it tells us that the graph kind of connects at that central location and then extends out from there, right? Now, what if you have, for example, 4? We'll put 4 in. And why 4? Because strictly 4 is something we can take the square root of, right? And we could have chosen 2, but the square root of 2 is not as pretty of a point as 4 plugged in and then taking the square root of 4 and getting 2. All right, we could do one more for good measure if you wanted to. You could do something like, x is 9 and therefore y is 3, right? The square root of 9 is 3. All right, so there's some points there that will work. So again, we don't use the point 1, 1, but again, we can kind of keep that open circle idea, right? Just to say, hey, starting at that point, and then if you go over to 4, comma 2, so on the x-axis, 1, 2, 3, 4, and then up 2 on the y-axis, so that would be about here. And then if you did 9, 3, I don't have 9 labeled on the x-axis, I only have 3, 4, 5, 6, 7, but you can imagine it'd be like 8, 9, roughly around there. And then we go up to just 3 on the y. So it's raising very slowly. As you know, this graph does raise very slowly, right? So about there. And so the graph would look something like this. And here you can extend and put the point at the end of the line to say it keeps going on and on, because we know that the function goes on to every x value greater than 1. All right, so that's the graph of our function. And essentially, if you wanted to describe the domain, that's pretty easy to see. We can get that right from this information here. It looks like the domain for the function goes from -4 inclusive, including -4. It goes up to 1, right? But it does not include 1, so we have to round the bracket for 1. And then we're going to start up at 1 again, but again, we won't include 1, and we go up to positive infinity. And again, you never include positive infinity, so we can use that round bracket. So that's the domain for the function. Now, for the range of the function, we simply have to look at what's happening on the y-axis, right? So you can see this pretty visually from the graph. We don't have any point that's going to be below y equals to 1. And we don't actually have any point that's equal to y equals 1. Remember, that's why we made this point here open, circled, right? So we're going to say that the range kind of starts at 1, but not including 1. And then it looks like it'll go up forever. Why up forever? Well, even though this point here is as high as we get on that portion of the graph, right? So in that case, you'd say, well, hey, it looks like 6 is as high as it goes for that little piece of the graph. That may be true, but over here, this is going to keep rising slowly and slowly, but it'll keep rising, 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 and over time, when x gets big enough, that will go up forever and ever, ever. So the range for the graph is from 1 to positive infinity.